All right, in this video, we're going to describe the shift of each of these different parent graphs compared to what they currently are. And so for a lot of these, we're going to list out, 3, 4, maybe even 5, 6 things that is being shifted compared to like our normal function. For example, this one is squared. So it would normally just be the function f of x equals x squared. That's the parent function. But here's all this other stuff around it that we need to figure out what it's doing, how it's moving compared to where we would originally start with just that regular function f of x equals x squared. So let's start here. We have 1, 2, 3, 4 of them. And the first one, which function is this to start with? The parent function, if you can think, is going to be the absolute value function. So let's write that down. Let's say absolute value. I like to just always start with what parent function it is. And then just kind of from left to right, it's a negative. So this is going to flip it over our x-axis. So we can say reflect over the x, or ROX, you might say. The 1/2 out front, whenever there's a number in front of your function, it's going to affect it vertically. If that number is smaller than 1, it's going to be a vertical shrink or a vertical compression, you might say. If that number is bigger than 1, it's going to be a vertical stretch. This is smaller than 1, it's 1/2, so it's going to be a vertical compression. And then I like to say of whatever number it is, in this case of 1/2. All right, and then again from left to right, the next thing I come to is this +3, and then the -4. The numbers on the inside and the one at the end affect this left and right and up and down. So the one on the inside is left and right. In this case, if it's +3, it's going to the left 3. And the number at the end, it does go the way that the sign says. So here, if it's -4, it'll be down 4. All right, down 4. So that's how you would describe the shiftings of this graph, or of that function. The next one, again, this parent function, since it's all being squared on the inside there, this is going to be our quadratic. So let's write that down, quadratic function. Different than the quadratic equation, by the way. Anyway, the next thing I come to is this negative. Now, this negative's on the inside, right? If you look, we have kind of 2 sets of parentheses, and the square is being squared to everything on the inside of that. So this negative and the 1/2 and the 7, that's all on the inside of my function. So this negative, if it's on the inside, it's going to reflect over our y-axis. Reflect over the y, or ROY, you might say. The negative, or the 1/2 that we come to, just like this one, when it was on the outside, affected it vertically. If it's on the inside and we have a number out here, that's going to affect it horizontally. And this is kind of the opposite of the other one. So here, if this is a 1/2, this is going to be a stretch, all right? Whereas if that number is bigger than 1, it's going to be a compression. So again, kind of the opposite of what you see over here. So this is going to be stretching it horizontally, or I might say a horizontal stretch of 1/2. Okay, those ones I think are the hardest to remember what does what. So if it's vertical compression, vertical stretch, horizontal stretch, or horizontal compression. So you might just have to kind of get good at those and realize what it does after several repetitions of practice. Okay, the next number I come to is this -7 on the inside. Again, this is going to move it to the right 7. And then the number at the end, the -2, this moves it down 2. Okay, let's check out our next one. This one is just our cubic function, right? If I took away the other numbers here, it'd just be x to the 3rd. And this one doesn't have a whole lot going on. We just have a 4 and a 7 with it. However, the 4, since it's out front, this cube is not affecting the 4. This is going to be a vertical stretch of 4, because that number is bigger than 1. So a vertical stretch of 4, always write what number it's happening to. And then the only other number that's here is this -7 that comes at the end of my function. So it's going to be down 7. So this one only had 2 things that happened to it. Right, this last one says f of x equals negative square root of negative 5x, and then outside the square root is +4. This, of course, is our square root function. Oh, and by the way, I probably should have said this is our cubic on the last one. So I suppose if you include that, there's 3 things. Here, start by saying this is the square root function. Okay, now this has a negative on the outside and a negative on the inside, and it is okay to reflect both ways. All right, it's going to reflect over the x, and then it's going to flip back and reflect over the y. So I'm going to say reflect it over the x and reflect it over the y-axis. Axes. Then the only other number, I guess there's 2. We have a 5 in here. That's on the inside, so it's going to affect this horizontally. This is going to be a horizontal compression of 5 because the number here is larger than 1. All right, remember, if it's smaller than 1 on the inside, it's a stretch. If it's bigger than 1 on the inside, like a 5, it is going to be a compression. So I'll say a horizontal compression of 5. All right, a horizontal compression of 5. And then the last number we have is just a +4. This is going to shift it up 4. So we'll say just up 4. So this one has 1, 2, 3, 4 different things, depending on how you count that. All right, that's how you describe the shiftings if you're given a graph like this.